Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco DevNet, and I'd like to talk to you today about how you can package, deploy, and run applications in the network with IOX. This is a lesson in our Network Programmability Basics video course, and we are in the application hosting and the network module. We're actually at the end of this module because we've already talked about why you might want to host applications in the network, using Linux at the edge for scripting and utilities, Python examples, and now we're going to look at how we can run real applications in the network using the Cisco IOX platform. If you'd like to follow along and code with me, I encourage it. Go on up to GitHub, github.com/cisco-devnet/netprog_basics. You'll find all the code available for this lab as well as all of the lessons in the course. Every lab includes a README with details on how to prepare your own environment, your workstation or your laptop, as well as which DevNet sandboxes you may need to use or reserve for this lesson. As we talk about IOX, we'll start out with a discussion about what exactly is IOX and why you might want to use it. Then we'll look at how you would actually get your own development workstation ready to build and deploy applications with Cisco's IOX. We'll look at packaging, deploying, and running an application in an IOX platform. And then at the end, we'll get away from slides for a bit and we'll look at it in a live demo. So, what is IOX? Well, IOX starts out as a platform that enables you to host applications at the network edge across different hardware platforms from Cisco. And applications is key. Different from what we talked about in the Linux and the Python lessons, now we're actually talking about real applications, business applications that may or may not have anything to do with the network at all. All we're looking at in IOX is providing a compute platform, an application framework, and a software development kit for application developers to build those applications. IOX gives all of the lifecycle capabilities to manage those applications from installation, upgrade, and then removing them from the environment as you go through. So why IOX versus other alternatives? Well, IOX builds on a distributed compute environment that already exists so that you can build FOG applications. And that distributed compute environment is the network infrastructure. We already have CPU, RAM, storage capabilities at all of our locations inside of the network. And for a long time now, our network devices, routers, switches, and others, have had more capacity than necessary for simply processing the network. And with IOX, we're taking advantage of that. Also, by building our applications inside of the network, we can take advantage of all the networking and security services that iOS offers. This gives us powerful integration so that we can have our IoT sensors connected to our edge network devices that provide that gateway to the cloud, middleware, and other integration services that are there. Now, the applications that can be built with IOX are as large as the mind can consider. We've got code support across Python, Java, JavaScript for Node, Go, or really any language you may want to do. Because the way that this works is through packaging technologies. You're not limited by what IOX supports because we can use Linux containers or Docker tooling to actually package up our application with whatever it requires. If your application doesn't make sense to be able to be containerized, we can run them in virtual machines using KVM. And then we have also a platform as a service for the lightweight Python and Java applications your developers may be interested in. Now, IOX is supported across a range of platforms from Cisco, including our ISR and ASR routers, specific industry or industrial devices like our IR integrated router gateways, our CGRs, UCS server platforms. There really is a wide variety of where you can run your IOX applications. Now, the core components to the IOX platform start with the CAF, or the Cisco Application Hosting Framework. The CAF is the actual framework running on the iOS devices. This is the utility that actually manages the spinning up and down of containers, launching platform services, or managing the virtual machines running in the network. IOX provides an SDK, a software development kit. Now, the SDK is what your application developers will use and install on their own workstations that help building and packaging those applications to make them iOX ready. Coupled with the IOX SDK is IOX Client. This is a command line utility that developers can use to package, install, deploy, and manage applications being hosted by CAF on the edge of at the edge of the network. Now, it's not all about command line utilities. We also have Local Manager, which is a web interface running on the IOX devices, on those switches and routers, that let you manage those local devices. So look at the applications that are deployed, install them, upgrade them, full management device by device. But when we talk about the FOG, device by device doesn't scale. And that's where FOG Director comes through. FOG Director is the IOX component, the overall management software that you can run to deploy your applications in the FOG. And because these types of applications are all about scale, FOG Director does support up to hundreds of thousands of devices from a single instance of FOG Director. And with that out of the way, let's talk about how you can actually get started using IOX for building and deploying applications. To do that, we have to get our development workstation ready, and so there's a couple of prerequisites you'll need for this example. Now, we do support multiple mechanisms for packaging up our applications with IOX, but the easy way to get started is with Docker. And we offer Docker tooling to convert Dockerized applications into something that can run with IOX. To do so, you'll need at least version 1.11 or 1.11 or greater for your platform. So if you're on a Mac, Docker for Mac, Docker for Windows, or Docker just for Linux will work for all of these. You'll then want to install IOX Client to make it easy to package and interact with your devices. Now, to support Docker, you will need version 1.4 or greater installed and downloaded into your machine. Once we've got the prerequisites in place, we can verify their proper versions with Docker version or IOX Client version to report back where we're at. Next, now that we have IOX Client installed, let's connect this to our platform, our environment, the network host that's going to be hosting our applications. And to do that, we create a profile using IOX Client. Now, a profile is a connection to a specific IOX device, and your workstation could have profiles for multiple devices. Maybe you've got different types of devices in your environment, or in this case, like I'm doing in this example, we're using the DevNet Sandbox to do our development against. So we create a new profile. In this case, we're going to tie in and provide access to the IP address of our IOX platform, the port information, username, and credentials. When you first run IOX Client, if you have no profiles, it will walk you through this process. Now, most of the settings, you can just take the default, making it very easy to get these new profiles set up. With that in place, the next step is to actually verify that we're successfully connected to our devices. In order to do that, what we'll do is run IOX Client platform info. This will then go through and report back the details about our platform that are out there. We can see the address information, all of the interfaces that are available. Now, you can look through all the details, but if you get the output like this, you know that your IOX Client is successfully connected to your network device. With our IOX Client ready, now we can talk about the actual applications. And this lesson isn't about designing or building applications, so our demonstration starts with an application ready to go, a very simple one we can use. Now, the minimum requirements for an IOX application are 3 files for these Docker style. We need a Docker file, which is the definition. It's the standard Docker definition for how to build Docker images. Main.py is a Python script that is our actual application that goes through. And then package.yaml is the IOX definition. It actually defines all the configuration and settings, things like how much CPU does this application require, how much memory, linkages to physical infrastructure or physical elements in the network. Maybe your application needs to be tied to a USB port or a serial port. All of that is defined inside of the package.yaml. Now, there are other optional files that you can include, but the minimum required are these 3. If we look at them one at a time, we'll start with the Docker file. There's not much difference between a Docker file for an IOX application than what you would use for a traditional Docker image. Every command inside of here is a different layer in how we construct the Docker image, and we can see that we're building from an Alpine image. Alpines are very basic Docker images that are thin, intended for these types of containerized applications. We're going to head and install Python and then install all of the requirements for our application that go through. To look at all of the Docker commands that are supported, because not the full range of Docker commands are supported by IOX, be sure to refer to the IOX developer documentation available on DevNet. Now, our main.py is our actual application. And what we have here is a very simple REST API providing this demonstration. We're leveraging Bottle, which is a very common, lightweight web framework for building REST APIs. And this application will provide two endpoints. One that will provide the current time at the device, and then another one that just reports back some basic status information that we can look at. And then finally is our package.yaml. As I mentioned, this is the configuration information for our IOX application. We'll see indications that the profile for this is a small. That ties back to specific CPU, RAM, and memory requirements allowed for this application. We can see that this application will have a single interface, and it's exposing port 8000, which is what our application is running on inside of our Docker. Now, one thing to note that is a little different than traditional Docker applications is that we have to specify using that target down at the bottom here in the output which application, which file, and how we start our app. In this case, python3 main.py. If you're familiar with Docker applications, you may be used to using the CMD, or the command parameter inside of your Docker file for this. Currently, IOX does not use that, and you have to specify using that target element inside of package.yaml. Now, with our application ready to go, we can move on to how we can package that application for running in IOX. The first step to that process is to actually build a Docker image that we will then deploy into our network using IOX. To build that, we'll leverage the same Docker build command you would use typically. So Docker build -t, the -t is a tag or a name for our image. In this case, we're naming it app_1. There is a dot at the end of the Docker build command, and this indicates the location of the Docker file that we're building. Dot indicates the local directory as we go through. So Docker build -t app1 dot. That will then go through and construct a Docker image for our application. With the Docker image created, now we need to package it in the actual format that IOX uses. And this will to do this, we'll leverage IOX client. Now IOX client, we've installed it. It provides all of the utility necessary. And so with IOX client, Docker package, and then -a to give it the name, app1. That will go ahead and convert the Docker image into a package.tar, which is the format ready to be deployed into IOX. With the application packaged, now we can actually deploy this or send it up into the IOX environment. The first step in this process is installation. IOX client application install, give our application a nice name, app1 for consistency, and then package.tar, which is that bundled application, or that bundled package that we created in the last step. This then installs this application by copying it up into the network device that we're targeting based on our profile inside of IOX client. Now the installation copies it up, makes it available. Now we need to activate that application, once again using IOX client. So IOX client application activate, and then our application name, app1. This then makes that application active and ready to be run. That lets us go through to starting the application. So we can have lots of applications installed or even activated inside of our device, but until we start them, they're not actually running. Once again, we're back to IOX client. IOX client application start. We can see the consistency in how this utility is very helpful for application developers for managing their applications with IOX, and it's a simple to use utility. So IOX client application start and our application name will then go ahead and start our application inside of our IOX device. And we want to check the status of that. We can do that with IOX client application info, and this will then return back in a JSON output all of the details from the host about this application's current running status. There is a lot of good information in here, but if we actually want to use our application, one we really want to look at is that port mappings. Now our application is containerized, and that inside of that container, we know our app runs on port 8000. We saw that in some of the other prep steps that we looked at. Now port 8000 with IOX gets mapped out to port 40,000 in this example to make this application available by targeting the end device, the network device that's hosting it. Now we've looked at how we can do this using IOX client, the CLI utility, which is the preferred mechanism for most application developers. But we do also offer GUI options to install and manage. Now those GUI options, as we talked about way at the beginning of the presentation, include Local Manager, which is a web interface running on each individual IOX node, as well as Fog Director, which lets you manage all of your IOX clients or all of your IOX devices across your entire network at scale. Now with the application started, we can actually verify that it's running inside of this demonstration. And we'll do that using Postman, the same API client we've used across a lot of the other lessons inside of this course. So we'll make our REST API query. In this case, we're going to make a GET request, and we will get to the IP address of our IOX device and then port 40,000 as we saw in the output from application info. We'll make our request for status and then device 1, and we get back our basic output that comes through as we saw in the code from Python. Now we've seen it in slides. Let's actually look at this application and manage it with a bit of the IOX client utilities that are there and then test that it's actually running. All right, so now let's take a look at how we can actually run and leverage applications using IOX. So IOX client application list will show us that I've already gone ahead and actually done part of the installation for this. So I use the IOX client application to install and activate, but our application is not started yet. So we'll do that with IOX client application. All right, application start, and then app_1 for the name. So I run this and it shows this now started. If I rerun that list command, we'll see that it is indeed running. Now if we run the application info app1, this is where we can actually see all of the details about this application in the system. If I scroll up, we'll see all of the information that we would need to access and leverage this application. And so we can see that inside of the network, it's been port mapping 8,000, which is the port that the application is written to run on, off to port 40,000. And so this gives us the ability to actually leverage this application and access it. So let's give that a try. If we remember right, this application is a REST API, so we'll go ahead and we will use Postman to do this test. So here inside of Postman, I've already got the API URI necessary. So it's this 10.10.2051 is our IOX end device, the host device for our application. Port 40,000 is the port that we've mapped off to, and then our application had the endpoint for status, if we remember. So I can send this call, status 1, and I get back the device status, device 1, system 1. There was another API endpoint, if you remember, which gave us the time. So I can do the time. And now I get returned back the current date time on the device. So we can see how those are going through. Now the IOX client utility that we saw in the command line is a great way for developers to work with this, but you may be interested in the other information about how well IOX is functioning. And so we do have the local manager running on the device. So here, let me go ahead and refresh this screen. There we go. So now we can see that our application is indeed running currently. Now I could stop this application through the web interface, just like we could use IOX client, and we can also go in and manage it to look at this application. Now it shows it's currently running, so I can't make changes, but this does let me look at the status. I can see that it's been assigned 200 CPU units, 64 megabytes of RAM, and 10 megabytes of disk space. Those correspond to this C1 small profile that's there. These other tabs kind of represent the same information we saw with the app info command from IOX client, as well as the configuration details that are there, and we can see what was loaded up. Inside of the app data directory, if this application was creating data, we would see those, and then we can also have access to the logs, the output of this application running on the edge device. All right, in summary, we've now talked about how we can actually build applications and deploy them in the network using IOX. We started out with a discussion about what exactly Cisco IOX is and all of the core components that it's built up by. We explored the options available for application developers to both build and then containerize or deploy them as VMs or using platform as a service. And then we walked through an example how we can use the Docker tooling available in IOX to actually package and deploy our applications to the network using the IOX client utilities. Now, as we went through on this, I definitely encourage you to go through and follow these demonstrations yourself. Get some hands-on with Cisco IOX using the code examples that were in the repo. Now, as you've gone through this, make sure you stay tuned for the rest of the Network Programmability Basics course. In our next module, we will pick up with NetDevOps and see how we can use tools like configuration management utilities such as Ansible to actually manage our full network configuration. Be sure to join DevNet for learning labs, as well as access to lots of development sandboxes for technologies like IOX that we talked about today. If you have any questions, feel free to reach out directly to me. You can find me on email or Cisco Spark at hapresto@cisco.com or hfpreston on Twitter, and on GitHub, my code samples are posted as hpreston. Cisco DevNet is available on all the social medias at Cisco DevNet. Thanks so much for joining me for this lesson. I look forward to seeing you for the next one. Thanks.